Hi, I'm Josh. Today I have with me Scott Haines from Databricks. He's going to both talk about and do a demo on Zerobus, which is a way for simplifying the ingestion process on Databricks. Take it away, Scott.
Awesome. Yeah, thank you so much. So I think this is something that is kind of interesting to me as well, as I've been working in like stream processing for about a decade. And so like Zerobus, like we're going to go through like a kind of presentation right now of what it is as well, and then essentially kind of like a zero to hero, walking through like a demo of what is possible with Zerobus, directly from my laptop as well. Let me kick over to the actual presentation as well. And so if we think about Zerobus, like Zerobus itself is like Kafka, but without the actual overhead of any kind of like architectural burden or any sort of, underlying like infrastructure burden. And so if you think about like the world of serverless, most things are becoming serverless because there's less to manage and, it's much simpler. But what does that actually mean? And so for people who are not kind of used to the Kafka infrastructure or not used to like Pulsar or, many of the different like streaming platforms out there, we're going to kind of do like a, 101 on Kafka and then kind of move into what that means for Zerobus as well. So what is Kafka? So Kafka really, for me, starting back in like the Yahoo days, this is what, 2013-ish or so, I had like my first introduction to Kafka prior to Kafka 1.0. And for me, it's sort of just like this magic system. It's a magic system that scales out almost indefinitely to handle like torrents of data. And so this was essentially kind of like that, also like that era of big data, right? Where it's like, everybody needs like, all data in the entire world to be able to solve their problems. Companies like Yahoo and Google and a lot of like the other kind of larger companies at that time did actually need a ton of data. But for the most part, most people don't need, millions of records a second that are being like ingested into like their, into like their lakehouse ecosystem. And so this is sort of where, Kafka is one of those decisions where does it make sense to run a bunch of different Kafka clusters to be able to scale out if your table might be like a million new rows a day. And so rather than having a lot of like this, like, the operational overhead of maintaining a cluster, Zerobus came out. And so it's still the same, idea, right? We still have producers. We don't necessarily have topics. We have tables. And so I, as a producer of data, essentially am writing, knowing that I'm going to eventually be egressing directly into a table. So we'll take a look at that in just a second. But really, I kind of buried the lead here. So here's the actual information, right? Like if I think about Zerobus, like the zero actually just means skipping like the actual bus. And while like Kafka is not necessarily like a traditional message bus, a lot of times we talk about it as a traditional message bus. And for anybody who actually cares, the difference between like Kafka, which is essentially like a log aggregator, and a traditional queue is really like the difference. And so a message bus used to just be a queue. You'd, essentially produce a record and you'd consume that and it would like no longer exist. But with Kafka, it allows you to, essentially continuously replay data within a topic until that's actually deleted. And so if you think about that, that's like really nice, but deletion policies are problematic if you want to be able to read for a long time. And given that, I'll just go back for a second, given that most Kafka topics require multiple replicas of the same data set, that also becomes like more of a cost burden over time, depending on the size of the topic. So if you have, 40 million records a day coming in, you actually have to store about 120 million records to make sure that you don't lose any data. And so that can scale, across all topics at a company, and it becomes, a gigantic overhead in terms of compute. So we skip the bus. What does that actually mean for us, right? In short, it's simplicity. Like, I want things to be easy. You would like things to be easy as well on your end as well. Everybody who's probably watching this also wants, things to be easier as well. And then it really kind of goes back to why we actually do serverless in general, because there's less things to actually think about. And so the one thing that I think is actually kind of interesting is, rather than having a lot of like kind of complex protocols that are introduced for Zerobus or like, a new format, a new standard for people to think about, instead I kind of go back to traditional REST or traditional gRPC, which were really big in like the API world. So if I have essentially like a gateway and that gateway ends up being managed directly by Databricks, there's again no infrastructure for me to worry about. That also means that as long as I'm creating APIs in the way that I would any kind of other productionalized APIs, I can just send data in a way that's, feels, not foreign to me, right? I'm going to go send data. I'm going to get back an acknowledgement. This is great. Life goes on, knowing that that data essentially is, emitted to Databricks and then read directly into an actual lakehouse table. And so like right now for that storage, we support Iceberg, we support Delta Lake, and we support Parquet as well. So, pick your poison, pick whatever works well for your company, but know that you can just emit data through the REST endpoint and it'll automatically be in that table for you. So no APIs to manage is great. And then if you think about, kind of more high throughput type use cases, we have gRPC. And so gRPC is kind of the connective tissue within like Kubernetes. It's been used a lot like across the board, inside of Google where it actually came out of. And it's usually used for kind of more high throughput, like exact use cases. So if I want consistent, services, typically I want to create a gRPC service because I'm essentially sending, I'm sending protobuf back and forth. I'm sending like a known data like shape, known schema back and forth. And that makes me a lot happier because as long as I'm ensuring backwards compatibility between releases of, my protobuf and then like my gRPC services, I can never send something that is incorrect. And so if you think about data and you think about high quality data, you want to make sure that things are correct. And so if you could literally just send correct data through a gRPC endpoint and have it automatically show up in a table, you've essentially erased like, a tremendous amount of typical, work, for most gigantic enterprises at this point, right? And so I think that's like one of like the really big selling points as well of Zerobus. You can use it in the small, you can use it in the large as well. And granted, I've already said this, but if we think about it, being able to emit data directly into a table is awesome. I spent like, I don't know how many years now, like as like, an ingestion kind of like foundation data engineer. And my whole job, the onus of like everything that I was doing was like, can I correctly read this data in a timely manner and write it to a table and have that be validated so that other people can actually read that downstream of me and trust that that data is correct. When you can simplify that whole entire process, I don't no longer need that to be in that position, but also for a lot of other jobs, the whole entire team that was working on ingestion gets to actually upskill and do work that matters a lot more than just making sure that data is flowing through correctly. And so those are kind of like the wins on that side. And so if we think about it, what we're doing behind the scenes in Zerobus is kind of similar to what happens inside of like a, typical kind of like a Kafka, cluster inside of the topic across like the distributed brokers. It's just a different mental model, different way of doing it because that's all essentially like, it's opaque to the end user. They don't have to ever think about it. But if I think about, I'm writing data of a specific type, say it's orders, which is the demo we're going to go through. Josh, you might be doing the same thing, running a lot of order data from a different endpoint as well, all to the same table. And so if we want to ensure that like the insertion order is correct, we want to ensure that, we're not having like, kind of like conflicts across the board in terms of like, I'm writing in a certain timestamp, you're writing in a certain timestamp. This is incorrect, like in terms of that sequencing. That's where essentially like this notion of like intelligent buffering comes into play. So I will buffer data as it's coming through behind the scenes in Zerobus. And I'm going to then write that into, in this case, it's the Delta Lake table for like this actual like picture, but it can be any of our other like managed, table formats as well. But the big thing though, is that like, if you're writing, say like you're reading off of Kafka traditionally, and it's essentially record by record by record by record by record. If I take each individual record or a very small batch of records and I write it, I'm going to essentially create what's called the small file problem. And so the small file problem means that it's a lot more costly for your downstream consumer of that data to go and read that. So you might have a table that has like, 100,000 rows, but if you have like, 5, 6, 7,000 Parquet files to encapsulate all that data versus just one, that becomes problematic for those reads. And so instead, we can actually use the intelligent buffer to be able to write down. And so if we're writing directly across our partitions into our table, we're good to go. And so Zerobus will do that all for you. All you have to do is essentially emit data to either the REST endpoint or to our gRPC endpoint as well, which we'll take a look at in a sec. So kind of getting to the crux, right? We use Zerobus for essentially optimal speed and layout, and also for cost controls as well, because we don't see a bunch of different replicas here like you would in a traditional kind of Kafka cluster, because we can guarantee that the writes are going to occur and that they'll actually land in like your table, which is essentially already, backed by like the, I think it's like this, I don't know, the 6 9 7 9s of like S3 storage and or, whichever hyperscaler storage format that you're using as well behind the scenes. And so, these are big things. These are, kind of big wins in general, but it's also, as we talked about before, like getting to the point where things are actually scaling correctly or performant is a little bit more difficult if it's not essentially managed for you in like a serverless way. So traditionally in Kafka, I'd have to think about, the sizing of the cluster, how many brokers they have, how many CPUs they have, how much memory they have. On top of that, I need to think about like how overloaded do I want a broker to be? So if a broker is essentially sharing part of like the data of an individual topic, it becomes like more of like a distributed, data problem. Typical kind of, it becomes problematic for you. So it's like, how do you partition? Do I partition by like, user ID? Do I partition by UUID? Do I try and figure it out over time? These things kind of change over time as well, in the same way that a table partitions might want to change over time. So I don't know, Josh, you probably talked about like liquid clustering on here before, but things change. The needs of a table change over time. The same thing happens with any kind of like any kind of like streaming system as well. The way that you distribute that data will change over time, and that's okay. But you shouldn't have to think about that. That's like the big, that's the big thing. And lastly, right, in the same way that I think about how am I going to, read it, how am I going to, emit a million records and ensure that that is, efficiently written to a table, within like a specific TTL so that a downstream consumer, has fresh data. A lot of times figuring out how to scale like what's called a producer record batch is a lot harder, because you're trying to like kind of, it's like kind of like knobs and, just tuning, right? Tuning in general can be difficult. It can take some time to make sure that things are, accurate and correct. If that's all done for you, then you win. So it's a huge win for that. And lastly, this is another Kafka thing too. If I want to ensure that every record that I write is not dropped, so they have like no lost data, there's no drop data, there's something called Axol. Axol can take more time, and then you're like, oh, this thing is slow. Why is this slow? It's like, well, it's slow because you're essentially waiting for all brokers that are, essentially assigned to your topic to essentially say, yeah, I got it. I've got this record. I'm all good to go. This is great. In-sync replicas have this. Don't worry about it. This is now a durable write. And so that can also be another thing too, where writing and ensuring that you have the correct number of replicas, just in case there's some sort of disaster, ends up being something that you have to think about as well, like on your path to production. Otherwise, some of the other stuff that people do is they just say, let's just use the defaults and hope that it actually works. It's more of like the YOLO model. And so if you don't have to think about any of that and you can just hit an endpoint like Zerobus, that makes life a lot easier. There's a lot of benefits we've talked about like with Zerobus in general, but really kind of the high level is like that performance at scale, right? You don't have to think about it. It's going to scale for you. And that's something that's very beneficial for anybody who's essentially like, a Databricks customer. Streamlining things across the board, being able to kind of choose like you're in an adventure. Am I hitting the REST endpoint? Am I hitting essentially the gRPC endpoint? Not having to really think about it and being able to use like the tools of my trade make a lot more sense. Like with traditional, eventing systems, it's either Java or it's Scala. It might be written in Go, it might be written in Rust. The nice thing with gRPC is that you can write it and essentially do it from anything. It can be from TypeScript. It could be from, even the web. So there's there's essentially like other kind of like other ways of essentially connecting and sending data that, this introduces a lot more possibilities than what was there kind of traditionally, which is great. It also works with everything else in like Databricks as well, which we'll take a look at. So it's, all the governance for Unity Catalog comes out of the box from day one. And so your APIs are essentially, access and authorization is all something that is fully managed by Unity Catalog at the API, which is really great because you don't have to think about a new way of securing your system just because you want to get data into Databricks as well.
That's very cool, man. That's a lot of information. And I'm sure some folks will probably want to go back and rewatch it a little bit. But how about not just telling us the theory and what's happening, but actually showing us? You have a demo for us.
Yeah, this is perfect. You set me up really well for this. And I'm calling this demo, essentially, it's like using Zerobus like a pro. You'll find that to use Zerobus like a pro, you just have to use it. Everything else is really just done for you, which I think is one of the really nice things. So let me go and pop up the demo. Okay, so we're going to start off in the workspace, and then we're going to kind of work backwards from here. And so what I'm showing right now is essentially a catalog called demos, because I'm giving a demo, and I have a schema called Zerobus. The important thing to think about for this, for Zerobus in general, is that I need to have essentially an S3-backed catalog or an S3-backed schema itself. So if we look at the details, I'll see that I have a storage location that's not using default storage. This is inside of my own S3. So I'm more than happy to show this because it's nothing that I'm worried about showing. No issue there. So right now you'll see that I have no tables, and that's okay because we're about to go create a table itself. So inside of this environment, I've created a couple things to just help as we showcase what is needed to essentially set up the Zerobus environment. And so what we're going to run right now is essentially called Bootstrap Demo. And we can talk about what's needed for all of this stuff after the fact. But I can also just share the GitHub for everybody who wants to go through all of this as well. So just as sort of like make, and if I do just Bootstrap Demo, what it's going to do is it's going to check first to see, do I have a table that's called orders inside of essentially demos, Zerobus orders at that path. And since we know that we didn't have it before, it checks and it comes back and says, hey, this doesn't exist, right? And so let's go and actually create this. And so one of the things that is interesting is that if I want to go and create a table for Zerobus, it has to be a managed table. And so we're essentially creating a managed table that also allows us to write to it externally, which to me is an interesting thing, right? Because traditionally, there's a lot of things that I feel like you had to be inside of the Databricks environment for these to run. And so a lot more of this external access through Unity Catalog makes me really happy. And so speaking of access controls, what we're going to do is essentially try and do anything else with this table. But first, we're going to go back over to Databricks. Okay, so within Databricks, we're just going to make sure that our table actually created successfully. So you'll see that we have this orders table. And what we had before is pretty similar to what we see over here, only it's a little bit harder to read when it's not beautifully rendered, right? It's not bad. It's not a bad overlay, but it gives us really all that same information as well directly from the terminal. So we know that we've created the table. We know that it's managed. We know that it has a actual external location as well. And so this is all the things that are needed for Zerobus to actually work. And so with that said, what we're going to do next is actually attempt to go right to this table. So we've done nothing yet to allow our service principals to write to this table. And granted, we'll see if this actually works because I did actually have this table before we dropped it. And so we'll see if the Unity Catalog grants still exist after the fact. So let's go through this one over here. And let's just demo Zerobus. I can actually type. So what we're going to do is essentially generate some orders that follow the same schema as what we have in our table. And we're going to go and produce 100. And then we're going to go and view the records. We're going to see if this fails, though, to see whether or not we need to go and actually apply new grant permissions after the fact as well. And so right here, we essentially have this OAuth request error. We have a client error. We're unauthorized. And this is the expected behavior. So if you think about it, right, if you applied permissions at one point in time, you dropped a table, that table no longer exists. Therefore, any kind of grant permissions associated with that table should also be cleaned up behind the scenes when you drop your table. And so this is essentially just showing that yes, Unity Catalog is working as expected. Going back over here. First off, we're going to accept our AI descriptions. That's great. You can go generate some columns while we're here as well, just for fun. I always kind of like this when you're creating new tables. And we'll just go with whatever Databricks says, because I trust this as well. So now we've got a table, it's got a description, we've got comments. This is going to be good for Genie later on as well. But one thing is that we know right now we want to be able to go and write to this table. And so from there, I'll take my client ID. And so to show you where the client ID actually comes from, I'm going to go into my settings. I'm going to go into identity and access, and I'm going to go into my service principals. And so a service principal is used for any kind of like non-human that will be doing something on your behalf. And so I have this Zerobus Ingest Demo app over here. I have this application. And so we go back over here now. So this is just the information for the Zerobus Ingest Demo app. We care about the identifier in order to be able to go and apply any kind of permissions to this. So we go back over here, go back to this playground over here. And so right now we'll see that this is like the ID of the service principal over here. You can take my word for it, or once this is, once you're viewing this recording, you can just slide back in time and take a look at it. So we've got, as we know, we've got the Zerobus, we've got demos, Zerobus, and we've got orders. This is a new table that we created over here. So demos, Zerobus, orders. Yay. So all we're going to do is go apply this. So we're going to apply grant use on the catalog to our service principal. We're going to do grant external use on the schema to the catalog, then grant schema on the catalog, and then grant external use schema as well to the client ID. And then we're going to grant modify and select on the table as well, so that we can actually write into the table and then read from the table as well. And this is it. So this ran over here just now, 2 seconds ago, right? And now we're going to go back. And now we're going to go clear this off. So now that we've updated the access controls for our service principal to allow it to externally write to our Zerobus table, the next thing we're going to do is just test to make sure that everything was working over there. So we're going to do just a simple. So if I do demo Zerobus, this is just going to take all the parameters for orders, for limit, and for count. And it's going to do a basic insert into the new table that we created. And after that, it's going to then query that table and take a look at the records that we have added so that we have an idea of what we just did. And so it'll take a little bit of time because it's generating everything in Python, which is a little bit slower than it could be. So once it's generated each individual record, it's taking that, and then it's emitting that through the Zerobus SDK as a part of a record. And so we now published 100 orders into Zerobus, and we're just going to wait for it to go and query that table, which looks terrible. So let's switch back over to Databricks itself, and then we can go and actually just query that itself. So we'll take a look at this one. We'll just run the top 100 over here, this 1,000. And so we'll see now that we have randomly, this is all random, so there's nothing here that's like sensitive information over there, but we've got line items, we've got subtotals, taxes, shipping costs, total, shipping addresses, billing addresses, payment methods, etc. And so what we've done is essentially create a bunch of orders that we can now use, as a synthetic data set. But the nice thing is that I did not have to run a single ingestion pipeline. I didn't have to create any sort of workflow. I literally just had to hit Databricks in a specific region and go from there. And that's pretty much it. So Zerobus is very easy to use. And it can handle like millions of events or records, depending on like what you want to call each data point that you've emitted to Zerobus per minute. And so like one of the big things I think that people would ask is like, when do you use Zerobus? And you use Zerobus for most workflows that require any sort of data that's being emitted from many different systems. That's not just ingest from like an Oracle database, a Snowflake database, like anything else like that, right? Like there's a kind of a traditional kind of like ingestion to the warehouse type flows, and there's all of these kind of like, real time, data flows as well. And so Zerobus is a really good candidate for that.
How does it compare to real-time mode, which I know was also recently announced by Databricks?
Yeah. And so it's like a really good question. So with real time mode, you're essentially like the thing that you care about the most is like, so taking a step back, if we think about the orders that we just created, like we were essentially buffering a batch of orders and we wanted to be able to reduce essentially what's like the small file problem by essentially having each individual event become a row in a database. If I think about real time mode, it's more of like, a fraud detection type thing, or, I as Scott am attempting to open up a credit card. And as that event is emitted and read through Databricks, I want to take action on exactly that one individual row. I don't care about any of the other rows. And so real time mode essentially goes from, it's a kind of a divorce from like the micro batch style of ingestion that Spark, there's a kind of Spark's, claim to fame, right? And now it's essentially like, individual event by event by event processing with the same kind of consistencies as like Spark structured streaming. And so you can guarantee that you're able to process each individual record, but also your guarantees are, it's like sub 500 millisecond for kind of end-to-end processing. When you think about Zerobus, the thing that you should think about is how do I essentially make it easy to write to a table? But I'm going to go query that table like it would any kind of traditional table. So I'm going to hit it with SQL. I'm going to hit it, from a Databricks app, anything else like that. And so they do differ, but we'll see how they converge in the future as well.
Awesome. Well, Scott, thank you so very much for your time. And just to make sure, this is available today, right?
Yes, I just so Zerobus is GA, and all of the code that I showed today for people who want to understand how it works behind the scenes and want to deep dive into it as well.
Well, Scott, thank you so very much for your time. It's a pleasure to have you here, man.
Awesome. Thanks for having me on as well. So like whatever day of the week, I'm like, happy Wednesday, right?
Happy
So,
Wednesday.
see you, dude.